Good afternoon all. Respected Chief Guest, Dr.M.Govindan Kutty, Dr. Shirley Teacher, HOD Department of Physics, ST College, Alappuzha, Dr. Sivisa, HOD Department of Physics, University of Kerala, Kariavattom, other faculty members at the Department of Physics, ST College, University of Kerala, and other departments of co-host colleges, and other dignitaries. A warm welcome to all. Indeed, this is a respected chief guest for Dr.M.Govindan ST College for hosting Dr. Shirley Teacher, the program, HOD Department of Physics, ST College, Alappuzha, Memorial Webinar, Dr. Sivisa, HOD Department of Physics, University of Kerala, Kariavattom, other faculty members. As you all know, the program aims to build or aims to spread physics concepts or physics knowledge among students community. The series will include lectures which will cover topics from different areas of physics, and I am sure the students will get a great deal of benefits from this program, and all those who wish to pursue physics as their career. I also take this opportunity to convey the wishes given by all the faculty members at ST College to this venture, especially our principal, Dr. P.R. who gave consent to conduct this program at ST College. Moving to my duty, at the very outset, I would like to welcome our chief guest, today's invited speaker, Dr. M. Govindan Kutty. A few words about the speaker. He did his undergraduate course in University College, Trivandrum. Then he completed his PG from QSAT. Then he joined IIT Kharagpur for his PhD course. Now he is working as associate professor at prestigious institution IIST Trivandrum. He has many papers and books in his credit. He is a great teacher, great speaker. Moreover, he is a great friend. I have some personal relation with him too. Today he will deliver the lecture on tropical cyclone and climate change. As you all know, Indian Ocean is one of the 6 major cyclone-prone areas of the world, and we are witnessing many cyclones during these days. And recently, Cyclone Amphan has aided the flood situation in Assam. So the topic has its own relevance, and I hope you will get a good informative session from Dr. M. Govindan Kutty. So, with great pleasure, I am welcoming our chief guest, Dr. M. Govindan Kutty, to this function. And personally, I thank him for accepting our invitation to deliver an invited talk in this webinar series. Welcome you, sir, to this function. Eminent personalities are here to give felicitations to this webinar. Professor V. Ramakrishnan, sir, former Director, IIST Trivandrum, Dr. Disha ma'am, Assistant Professor of Physics, Maharajas College, Ernakulam, Dr. Srijit K. Pisharadi, Assistant Professor of Physics, ST College, Alappuzha, Dr. C.B. K.S., Head of the Department of Physics, University of Kerala, Kariavattom. On behalf of Department of Physics, ST College, I welcome you all to this function. HOD of my department, Dr. T.R. Shirley Teacher, is here to propose the vote of thanks. She is also an alumnus of Department of Physics, University of Kerala, Kariavattom. With great pleasure, I would like to welcome Shirley Teacher to this function. Next, I would like to welcome the faculty members at the Department of Physics, ST College, Alappuzha, Department of Physics, University of Kerala, Kariavattom, and all the members of the organizing team and all the faculty members at various departments of the co-host colleges. So on behalf of Department of Physics, ST College, I welcome you all to this function. Before closing, I would like to welcome the students participants who registered in this program from various colleges all over Kerala. You are the targeted participants of this program. So welcome you all to this program. So once again, I welcome you all to this program. Thank you all. Next, I would like to invite Dr.M.Govindan to deliver the keynote address.
Sorry, Rakesh, in between I missed. So can I start presenting now?
Yeah, you can start, sir. You can start now.
Yeah.
Okay.
All right.
All of you others, please mute your mic, please.
Where is it? Can you see my slide now? Rakesh, can you see my slide?
Is coming, I think. Not yet.
Okay.
Sir, did you share the screen?
I think so, yeah. Just a minute.
Okay.
How about now?
Yeah. Okay, sir. It's viewable. Thank you.
Okay, so thank you, Rakesh, and the other organizers of this meeting for inviting me here for this lecture. So today I'll be presenting on tropical cyclone and climate change. Dr. Govindan Kutty from Indian Institute of Space Science and Technology, Villamala. So the reason for choosing this topic, the severity of tropical cyclone has increased in recent decades. This has triggered to a speculation that tropical cyclones is linked to the climate change. So as we all know, as the studies shows, our climate is changing. So the increased intensity or increase in the number of tropical cyclones, is it related to tropical cyclones by any way? So in today's talk, I will address the science behind the genesis, growth, and dissipation of tropical cyclones. And we'll also explore whether there is any linkage of tropical cyclone intensity or the number to the climate change. So let me begin my lecture. I'll just start with some history. Okay, so with a debatable statement, I'm starting this presentation. So the statement is like this: if there were no tropical cyclones, Japan may not exist in our world map. So you may ask this question: how is tropical cyclones connected to Japan and its existence? So that has some history. You may have heard of the famous Genghis Khan, who is actually the emperor of the Great Mongol Empire. And he has his son, grandson, whose name is Kublai Khan. Kublai Khan was also equally famous as Genghis Khan, and he is the one who has actually established the Yuan dynasty. Kublai Khan is actually instrumental in integrating the northern and southern China and made it as one country. So after integrating the southern China to the northern China, he then decided to conquer Japan. So Kublai Khan was very powerful at that point of time, and his army was very powerful. So he set forward to conquer Japan via sea coast. Okay. So once he reached the Japanese coast, so just before that, I just want to add that as compared to the Kublai Khan's army, the Japanese army is very inferior. They could have been easily defeated by the Kublai Khan. As I mentioned before, at that point of time, Kublai Khan was very powerful. So once he reached the sea coast, the very fine day, what has happened is that a very strong tropical cyclone made a landfall on Japan. So this has actually devastated Kublai Khan's army, and Kublai Khan has to return empty-handed to his kingdom. So this then, after several years, again he decided to conquer Japan. He set forward once again with even more great army towards the Japanese coast. The second time, when he reached the coast, the same events repeated. Another cyclone, which has reached the coast on the very same day, the Kublai Khan has reached the Japanese coast, and once again, it has actually destroyed Kublai Khan's army. You can see the depictions on the bottom of this slide, how his army has been, destroyed by the tropical cyclone. Once again, Kublai Khan has to return back to his kingdom empty-handed. So, since this is repeated 2 times, and the Japanese actually believed that this is Hurricane Irma. So they are actually on their way to the eye of Category 4 cyclone, Category 5 cyclone Hurricane Irma. So it is basically, you can see there are a lot of turbulences when they move through the cyclone, and very dark clouds also. See, once they reach the eye of a cyclone, there is no clouds, and it is in fact, you can see it is very clear from inside. You can see the very blue skies on the top, and there is no tropical cyclone. So energy is over land surface. You may not, the heat energy is converted to mechanical energy or kinetic energy, I would say. So heat energy is converted to kinetic energy. We might have studied that in our college classes, that a steam engine does the same purpose. Is the vertical axis, and R is the radius, which is given on the bottom. You can see that A to B, it undergoes isothermal expansion. From B to C, it is undergoing an adiabatic expansion. Is an inefficient heat engine. Hurricane is almost like an ideal heat engine. Actually, the frictional dissipation will help, which is basically due to the friction, the heat is actually fed into the system. It is not lost in the case of a hurricane, just like unlike the automobile engine. So, which makes the hurricane almost like an ideal heat engine, whereas the automobile engine is an inefficient heat engine. The working substance for an automobile engine, as we all know, is petrol, diesel, whereas the working substance of a hurricane is moist air, water droplets, and ice crystals. This is basically driving the hurricane. Now we will talk about. So I hope that you understood where does the cyclone derives the energy from, and how does it converts heat energy to mechanical energy. Now let us talk about the genesis of a tropical cyclone. How does a tropical cyclone form? So I'm just giving you a simplified view of the formation of tropical cyclone. It may not be scientifically rigorous. I'm assuming that I have a general audience before me. So I'm just that's why I'm giving a simplified version of the formation of tropical cyclone. Due to some reasons, or due to intense heating at one location of the ocean, air over a region becomes warmer. So as we know, a warmer
ഇല്ല വേണ്ട വേണ്ട വേണ്ട
And the fourth one is vertical wind shear. So in order to form a cyclone to form, you should have a weak vertical wind shear. I will explain what a vertical wind shear is. In the top figure, you can see there are several arrows, which is actually in vertical, moving in vertical. The arrows represents the wind speed. So the wind speed actually, as you can see from this figure, the wind speed increases with respect to the height. So there is a change or variation in the wind speed with respect to height. A change in wind speed or wind direction with respect to the height is what we call as vertical wind shear. I repeat, a change in wind speed or wind direction with respect to height is what we call as vertical wind shear. In the presence of vertical wind shear, a hurricane never forms. Just imagine you have a top which is having which is rotating in its own axis. So if you apply an external force, the rotation will stop. It will actually become unstable and it will fall down. Just like this, the wind shear makes the cyclone tilted. So once that system is tilted, you will not get that system is disrupted, and this latent heat energy cannot be focused over one region. So the cyclone starts dissipating. So in the presence of strong vertical wind shear, a cyclone will never form. So a weak vertical wind shear is a very important component for the formation of tropical cyclone. Now the last one is the trigger. So even if all these conditions are present, you need a trigger to the formation of tropical cyclone. Trigger as in a wave which is forming in the atmosphere, which can supply some kind of instabilities in the atmosphere, is an example for a trigger. This trigger is just like a spark plug in your petrol engine. You have fuel inside in your car fuel tank, but you require a spark for starting your engine. So trigger is just like that. So a trigger is required. Even if all these conditions are satisfied, a trigger is required for the formation of tropical cyclone. If all these conditions comes together, a cyclone will be formed. Okay, now I am moving on to the second part of this presentation, which is about global. The title itself is about linking the tropical cyclone to the climate change. Now that I've explained all the dynamics and physics of tropical cyclones in general, now how is this related to the climate change or global warming is the main topic of discussions today. So I'm not going to give any details about global warming, climate change, as I think you people are more aware about all these things. So the today's talk will only try to connect tropical cyclones to the climate change, and no explanations on the climate change is provided in this presentation because that's very vast. So in one slide, I'll just try to convey what a global warming is. So from the sun, the radiation reaches the Earth's atmosphere. Earth's atmosphere is transparent to the shortwave radiations which is reaching from the sun. It passes through the atmosphere, reaches the surface. Surface absorbs it and emits the radiations in the form of IR radiations. IR radiations will be captured by the greenhouse gases in the atmosphere. Greenhouse gases are important because otherwise the Earth will be very cold. But the amount of greenhouse gases increases will cause global warming. We are burning fossil fuels and emitting a lot of carbon dioxide into the atmosphere, and this emission causes absorption of more IR radiations, which will lead to global warming and resulting climate change. How is this global warming affecting tropical cyclone intensities or tropical cyclones as such? One pathway is like this. Global warming increases the sea surface temperature, and sea surface temperature increases evaporation. It increases moisture availability, which further enhances, the large amount of moisture in the atmosphere fuels the storm, and the possibility of having more storms or high inter storms are there in the future. So that is one pathway through which global warming can influence the hurricane activity. So I'm just going to tell you a story about Hurricane Harvey, which is formed over Atlantic Ocean. I'm just picking this Hurricane Harvey for a reason. I'll tell you later. So this cyclone has actually formed over Atlantic Ocean. It has then moved on towards the Gulf of Mexico, made landfall over years, as you can see from this figure. Then it it made a landfall over one region, then it again came back and made a landfall over another region, and it dissipated. And you can see the flooding which is caused by the Hurricane Harvey in the United States. Now the question is that why did I pick Hurricane Harvey? It is the first Category 4 cyclone which is to make landfall after 2005 in the United States. It is one of the costliest cyclone which amounts to almost like 125 billion. And this is actually the wettest hurricane in the recorded history of US. So these are not the reasons because I picked the Hurricane Harvey. It is because the Hurricane Harvey showed signals of changing climates in the tropical cyclones. What are those signals? This Hurricane Harvey stalled out over one area for a longer period of time. Second, it has dumped record rains for several days. Third, the rapid intensification. These three are signals of climate change or changing climate in that cyclone. Now I'm going to explain each one of this one by one, how this is the representation of the changing climate in the tropical cyclone. So the first, let us address the first one. Stalled out over one area for a longer period of time. That means the cyclone has not moved from one place for a longer period of time. So it has been established by previous studies that the climate change causes slowdown in global circulation. Global circulation is something which I mean by large-scale wind circulation, which is of the order of which is of the scale of some 20,000 kilometers, is what we call as global circulation. So it is already established by climate scientists that when there is climate change, it will actually reduce to global. It will reduce the speed of global circulation. Now the question is that how is this connected to hurricane, and how is it connected to the movement of hurricane? So for that, I'll just give you an analogy. Just assume that a ball which is floating in a stream of water. Okay, so the direction of this ball, or the direction in which the ball moves, depending upon the direction of the stream. If the stream is moving fast, the ball will move fast. If the stream is moving slow, the ball will move slow. It is moving towards the west, the ball will also move towards the west. Okay, so just like this, imagine this ball to be a hurricane, and the stream of water is basically the global circulation. So hurricanes are just like a floating ball in the global circulation. So in which direction the global circulation moves, that direction the hurricane moves. You might have observed that the cyclone always shows a westward movement, which is formed over Bay of Bengal. Okay, a cyclone which is forming over Bay of Bengal generally falls over Orissa coast or Andhra coast. Sometimes it goes to Bangladesh, and even sometimes it recurve and go to Myanmar. So different directions the cyclone moves. That movement of cyclone is what we call as a translational speed. That has nothing to do with the wind velocity. Wind velocity is something else. I'm talking about the movement of a cyclone as a system. So that depends upon the global circulation. So when the global circulation slows down, what will happen is that the cyclone, normally the tropical cyclone will also slows down its motion. That is being observed in Hurricane Harvey. The Hurricane Harvey actually moved very slowly as compared to the previous cyclone. That may have some connections to the global slowing down of the circulation. Okay, so that is one signal which we have got from the Hurricane Harvey. The second one is the Hurricane Harvey has dumped a record amount of rainfall in a given in over years. So why is dumping of record rain over a given region how is that connected to climate change? For that, I'll just give you a statement which is actually says that warmer air can hold more water vapor. So when the globe warms, when there is global warming, the Earth's surface gets heated up. Similarly, Earth's atmosphere will also get heated up. So the Earth's atmosphere is warmer than previous decade, which means now the Earth's atmosphere can hold more water vapor than before. So how will I explain that? So for this, an example is given on the left-hand side of the figure. You just imagine there is a closed vessel, and some water is kept inside, some pure water, and there is air above it, which has no water vapor in it. Now, if I slowly heat this water from the bottom, what will happen is that it starts evaporating. Evaporation means the water droplets or water will get converted into water vapor molecule. So now the air will have more water vapor molecule. Now, there is another process will also happen hand in hand, which is actually the condensation. So just like the evaporation happens by converting water molecules to water vapor molecules all will get converted into water droplets and reaches the surface. So these two processes happens hand in hand within the cylinder or within the box. So when the evaporation rate becomes equal to the condensation rate, we call that as saturation. When the condensation rate is greater than evaporation rate, we call that as supersaturation. Clouds form in a supersaturated conditions. That means when the condensation rate goes up or increases beyond the evaporation rate, you will see the clouds forming. So the point here is that how does a warmer air holds more water vapor? So for this, I'm just imagine that I'm heating this air above from the top. So when I heat the air above from the top, or that means I'm not heating the water below. I'm heating the water. I'm heating the air above the water. So what will happen is that the evaporation rate will remain the same or may increase. The condensation rate will steadily go down. When the condensation rate, when it goes steadily down, what will happen is that now the air will have more water vapor than before when I heat this air from the top. Okay, so now the air per volume of this air, you will have more water vapor molecules than before when I heat it. So that is the meaning of warmer air holds more water vapor. This can be established via Clapeyron equation, which you might have studied, which basically relates the saturation vapor pressure to the temperature. As the temperature increases, the saturation vapor pressure goes up, and which indicates that the warmer atmosphere can hold more water vapor. So when more water vapor is present in the atmosphere, when conducive situation comes in, when the situations become conducive, it will cause formation of clouds, and it can cause thunderous precipitations, very strong precipitations over a given region, because the amount of water vapor available at that given location is more due to the global warming. So this can in fact produce large precipitation over a given region. And that is supposedly one reason for having very strong rainfall, record rainfall in the case of Hurricane Harvey. Because of the global warming, or the atmosphere, the capacity of water vapor holding capacity of the atmosphere has increased. It has produced stronger clouds, larger clouds, which has produced larger precipitation and flooding due to Hurricane Harvey. That's why I said, so this is actually a signal of changing climate or global warming. This is one way through which it can affect climate change or global warming can affect the cyclone. So what we can expect in a global warming scenario is that the cyclones which makes a landfall on our coast is now possible to produce more stronger rainfall than say 10 years before due to the global warming. So the third point was, the global warming enhances the water vapor holding capacity of the atmosphere. It is estimated that for 1 degree Celsius warming, the saturation specific humidity increases by 7%. That means the water holding capacity of atmosphere increases by 7%. That is computed from Clapeyron equation. And increased water vapor content increases the intensity of the storm and associated rainfall. The third one is the rapid intensification of Hurricane Harvey. The wind speed, when the wind speed changes by almost like 55 km per day, then we call that as a rapid intensification. That means the cyclone will remain as a low pressure system for a while. All of a sudden, in 24 hours, in one day, it will become a super cyclone. Just like what we have seen in the case of Umpun cyclone. So in 12 hours of time, it has become a super cyclone from the depression. So warmer sea surface temperature results in rapid intensification, and global warming causes warmer sea surface temperature. The rapid intensification, which was actually a rare phenomenon before, now has become more frequent. And this is possibly shows as a signal of climate change, the rapid intensification of tropical cyclones. So that is another signal which we have got from Hurricane Harvey. So taking all these things together, we can assume that the climate is changing and it is actually affecting the tropical cyclones in various ways. What we can expect is that the cyclones are going to become more destructive in a warming scenario. Now let us give an attention to our North Indian Ocean. Tropical cyclones over the Arabian Sea was very. We rarely see, we could see very few cyclones over the Arabian Sea, say 10-20 years before, but now it has become more frequent. One reason is that the wind patterns over the Arabian Sea is weakening due to the climate change or global warming. When the wind pattern weakens, what will happen is that the vertical wind shear is going to diminish. When the vertical wind shear diminishes, as I mentioned, when the vertical wind shear is weak, the possibility of formation of tropical cyclone is larger. So the environment over the Arabian Sea or Bay of Bengal has become more conducive for the formation of tropical cyclone due to the climate change. That is something which we are observing now. Recently we have seen one of the strongest Arabian Sea cyclone, which has caused unprecedented destructions over Oman region. Usually we observe one tropical cyclone per year in Arabian Sea, but in 2019, 5 tropical cyclones has developed over Arabian Sea. And this year, 2020, we have seen a twin low pressure system over the Arabian Sea. So the frequency and the intensity of tropical cyclone are increasing over the Arabian Sea and even Bay of Bengal. You've seen the case of Umpun cyclone, which is actually formed on May 2020. This is the first ever super cyclone after Odisha 1999 cyclone, and it has intensified in a surprising time. It is in 12 hours of time. It has reached a super cyclonic intensity, which is very rare in the case of Bay of Bengal. We rarely see such things. The sea surface temperature was anomalously warm during the formation of Umpun cyclone. So that could be one signature of global warming, but there are another group of scientists who says that is the anomalous warming which is formed due to which has caused the rapid intensification of cyclone Umpun is not due to the global warming. It is due to the COVID lockdown. So what is the relation between Umpun cyclone and COVID lockdown? So we can see then the top figure 2019 and 2020, which is actually giving you the aerosol optical depth. So you have to understand that the dust particles in 2019 was is very high over Indian region. Now by 2020, what happened due to the lockdown? The air pollution rate has come down. The number of aerosols in the atmosphere, the number concentration of aerosols in the atmosphere has come down. So what the result is that, so when there are a lot of aerosols in the atmosphere, so the radiations from the sun will be scattered in various directions. So in the absence of these aerosols, when there is less pollution, what will happen is that more amount of radiation reaches the ocean surface. When more radiation reaches the ocean surface, that is going to heat the ocean surface anomalously. So it is possible that the warmer sea surface temperature anomalous warmer sea surface temperatures happen due to the COVID lockdown. So there may be a link between Umpun cyclone and COVID. The paper is still in review, but it needs to be established scientifically. So it is possible that the Umpun cyclone, the intensification of Umpun cyclone, may have some direct linkage to the COVID lockdown. Okay, so these are the projections from the IPCC for the future. How does the tropical cyclone is going to change in future? So the first point may surprise you. It has been the IPCC is not very confident on the first point, but it is as of now the result states that there will be either the same or decrease in the number of tropical storms. We actually expect that due to the global warming, the number of tropical cyclone is going to go up. But the results, the scientific study shows, is not giving a conclusive result. This is not a conclusive result because there are a lot of uncertainties in it. But with the current data, what we understood is that Either it will be the same or it will decrease. The number of cyclones will decrease. But one thing which will happen for sure is that when the cyclone forms, that is going to be very intense. So the possibility of frequent intense storm is higher. The rainfall rates is going to be very high due to the above mentioned reasons. And there is also a reduction in the translation speed of the tropical cyclone. I think I have explained the physics of all those things and how the reduction in translation speed happens and how the rainfall rates decreases. So this is something which we should expect from due to the in the future in a global warming scenario. And now, one last question is, so as of now, we have discussed that climate change and how the climate change is affecting the number and the frequency of tropical cyclone. But there is another question. Does the formation of tropical cyclone has some impact on climate change? Or the tropical cyclone, will it impact climate change or we can produce a climate change? Actually, it may be, it may not be a straightforward question, but it has not been established to date. But it is possible that there is a relationship between the tropical cyclone and climate change. That means the tropical cyclone changing the climate. So there is something which we call as thermohaline circulation, which is seen in the oceans. That is responsible for transporting heat and from the tropical regions to the polar regions. Tropical regions are receiving a lot of heat from the sun. Polar regions are receiving less heat from the sun. So in the absence of this circulation, what will happen is that tropical regions become more and more warmer. Polar regions become less and less, more and more colder. So because the circulation exists, it is in a kind of balance. So the turbulence generated by tropical cyclone over the tropical regions is one of the driving force for this thermohaline circulation. So just assume that if there is no tropical cyclone which is forming over the tropical oceans, then the turbulence over the tropical ocean is less. This in fact reduces the thermohaline circulation, and this in fact increases the temperature of the tropical region and increases the cold weather over polar regions. It is possible. So there is also a link between tropical cyclone, and tropical cyclone may influence the climate change as well. So it is a two-way system. Okay, I'll just conclude. So something which has not been discussed in this study is that whether the tropical cyclone is direct connection to the anthropogenic or it is natural. So I said that it is because of the global warming, the tropical cyclone frequency intensity is going to change. But we are not sure is it because of human-induced cause or it is a natural causes. From 1900s to 1940s, the activities of tropical cyclone was very high. From 1940s to almost like 1980s, the tropical cyclone activity was very less. From 1990s onwards, it again picked up. So there is actually a natural cycle in decades, which we call as decadal variability. So naturally, also the number and frequency of the number of tropical cyclones and its intensity may change. That is a natural cause. That has nothing to do with human-induced emission of fossil fuels or carbon dioxide. But it is possible that it can be. So it is very difficult to delineate between natural and anthropogenic cause. It is just like a milk mixed with water. It is very difficult to separate how much is contributed by anthropogenic and how much by natural. So that has not been discussed in the study. Ancient minds believed that the storms are sent by God to punish them for their behavior. So if you ask me, we have not traveled farther from Mayan era. I would just replace the name as God by nature. So I would say that storms are the medium through which nature punishes us for our deeds. Tons of fossil fuels are emitted into our atmosphere every day. We do deforestation, we cut down the trees, pollute our oceans, atmosphere, disturb the ecosystems, and we do all these things which is making our nature furious, which is actually disturbing the balance of the nature, which is responsible for the formation of more and more furious cyclones. So we need to be careful in dealing with the nature. We should have development, but it should be sustainable development, and we should be more careful in using our renewable resources. That's something which I would like to say at the as a concluding thing. And I would acknowledge is the book which is called Divine Wind, which is written by Kariavattom. It's a very really good book for a general reader. I would suggest everyone to read that book if possible. It's very interesting to read this book. So most of the things which I shown in this slide are from Divine Wind. Then I've used Google Images and Dr. Vinod from IIT Bhubaneswar for providing me the last picture for which connects the open cyclone with the COVID. And I've referred several scientific papers. I'm not citing it here. And thank you. So that's it. Rakesh.
Thank you, sir. Hope you all enjoyed this session, and the session was very clear, starting from the history of hurricane to the latest advancements in it. So now we are moving to the felicitation part. And the students, if you have any doubts, please comment your doubts in the comment box, and we will share these doubts with the speaker. So we are moving to the felicitation part now.
Distinguished persons who have joined this online platform, and my dear friends, I am happy that we had a great session with Dr. Govindan, Associate Professor IIST. This is the second program scheduled in Professor G.Aruldhas Memorial Webinar Series. I appreciate the sincere efforts from Department of Physics, ST College, especially Dr. Rakesh Chandran, my dear friend, to associate with this venture. During the inaugural session, we had a number of requests from many of our participants to talk about climate change. It is nice to hear from Dr. Govindan in detail about the tropical cyclone and climate change. In this contest, I have to tell that we are a group of 16 plus 1, 17 institutions joining hands to celebrate the joy in sharing knowledge taught to us from a great teacher, Professor G.Aruldhas. Myself, my sister, my father, and my mother all studied physics from Aruldhas sir. I am sharing a few photos of his home for you all to see. These were the same places where we sit together and definitely eat snacks and then do problems, share thoughts in various branches of physics. I had the privilege of teaching with him. Aruldhas sir often used to take 3-hour morning session in quantum mechanics, while I used to take solid state physics in the afternoon 3-hour session. In between, we had about half an hour to talk. And he always talked about science. That I have to mention. He always talked about his plans in writing new books. His thoughts were always in research areas and how he can establish a good relation between a teacher and a student. I should say, his thoughts never contained gossips. Once again, thoughts contained zero gossips. People remember him for that. I should add that he lived ahead of times where he treated students as his friends. I am still trying to imitate his ways. And this venture is a humble effort in these lines. Once again, my wishes for the success of the program. Let more programs be planned in the same platform for knowledge sharing, as well as let us meet eminent persons. Let us hear from them. Let us share their expertise in the concerned field with everyone. We, in the comforts of our home, do pay homage to this legendary teacher who made this platform possible. Once again, thank you all and best wishes.
Good morning to all. I am very happy to note that alumni and faculty members of Department of Physics, University of Kerala is organizing Prof.G.Aruldhas Memorial Webinar Series. Indeed, it's a great pleasure for me to be a part of this event. In 1983, I joined with him as a second student working on Raman scattering. Initially, we had a lot of problems in making the Raman equipment to be perfectly all right. Myself and Dr. K. Vishwanathan spent a lot of time on all this. And all the times, he has given me a lot of encouragement and has given us full freedom to work on this equipment. And which I appreciate on Professor Aruldhas is that he spends a lot of time with his students on evaluating their research manuscripts. He was very patient and he was listening to us. Whenever there is a difference of opinion on a particular point, he says he will think about it and come back to me next day. So I will go back to my room and used to think and I used to feel that whatever he said is correct. And another admiring quality is that he has very high human values, which I learned from him and it has helped me a long run to be a good administrator at IIST Trivandrum and also the head of the Department of Physics at Madurai University. Indeed, I appreciate everyone who is contributing for this webinar series. Wish you them best of luck.
Hello everyone, I am Sheba. I am currently working as Assistant Professor of Physics at Maharaja's College of Now. When Dr. Sibi called me and asked me to express my memories with Aruldhas sir, I recalled my youthful days. I met Aruldhas sir when I was doing my MPhil in the year 1991. He taught us quantum mechanics and he was the HOD at that time. He was working on a book based on quantum mechanics and he gave us handwritten copies of the same that was very useful for us. He got retired at the same year. The last time, in 2005, I met him during an interview at PSC office where he was the subject expert. He was a loving and caring teacher. I can list out various instances, but with the limited time, I am shortening my words. I was one of the lucky students who could experience his teaching. And lastly, I thank Dr. Sibi for giving me an opportunity to express my gratitude towards Aruldhas. Thank you.
Good morning, everybody. It is my great pleasure to be a part of the webinar series jointly organized by Department of Physics, Kerala University Alumni Association, Department of Physics, Kerala University, and SD College, Alappuzha, in memorial of our great teacher, Dr. Aruldhas. One of the great losses in my life is that I could not get the opportunity as a student of Dr. Aruldhas. But many of his students, like Dr. Jayasri V of DB College Shastankota, taught me during my graduate level and postgraduate level. From the words of JC teacher, I could understand how eminent persons like Dr. Aruldhas are taught the subject as well as inspire the passion of students. After that, when I joined for my PhD course at MG University Kottayam under the guidance of Dr. C.S. Menon, who was a close friend of Dr. Aruldhas, I got several opportunities to interact with him and serve him during his visits at MG University. Aruldhas are still inspiring, imparting knowledge to the younger students or younger generations through his students and through his writings. I appreciate the efforts made by the organizing team to conduct such a webinar series throughout in this state. On behalf of our college, our department and our students, I wish all the success of this program. Thank you, everybody.
Sir, hello. Hello.
Hello, I can hear you.
Yeah. So, dear students, if you have any doubts, you please share. Sivi sir, are you there?
Yes, sir, I am here. I am here.
In the meantime, you can interact. I'm just searching, but no doubts are displaying in the comment box. Students, if you have any doubts, please share. Yeah,
there is one doubt. I think there is Meena Verma.
And also Rakhi.
Would like to know. Yeah, there is one, sir.
Okay, sir. Sibi sir, please continue.
Would like to know whether there are studies showing any relation of hurricanes to solar cycle. Govindan, sir?
Yeah, so I can hear you. So the question is whether the solar cycle has any effect on a tropical cyclone. Actually, to my understanding, the tropical cyclone is affected by solar cycles. The study has not been conducted over Indian domain, to my understanding. Over Atlantic Ocean, there are certain studies which has been conducted, which states that the probability of a hurricane which is hitting the US coast increases during high solar activities. It can actually increase from around 70% to 90% when the SSN or solar activity is very high. That's what my understanding is. There are studies which has done connecting the solar cycles and the tropical cyclone. Yes, but not over Indian domain or not to my understanding.
And also, I think Rahimol, she also raised the similar question whether the solar activity affect the cyclones. I think she also got the answer right now.
So the physics is the solar activity can definitely influence the formation of tropical cyclone, because the tropical cyclone is depending on the warmth of or the temperature of sea surface. So the temperature of the sea surface depends upon the amount of input of solar radiations. So as the solar radiation increases, it can, ideally speaking, it can actually increase the solar activity by increasing the sea surface temperature. So there is a link between that, because the solar activity during this high solar activity, the amount of radiations are going to be on higher side. So this can in fact affect the hurricanes. But a study which has established this is done over the US coast or Atlantic Ocean, not over the Indian domain. I have not seen any studies over Indian domain like that. Or maybe I missed, I don't know.
And another one is related with career. Sir, what are the career opportunities in the climate science for a physics graduates? Raised by Siddharth Evi.
Okay, career. I mean, if you're talking about higher studies, the an atmospheric scientist requires a background in physics or mathematics, because most of the problems we are solving is either mathematical and physical, and opportunities are after completing your BSc, you can join for MSc programs in atmospheric science. In KUSAT, there is a MSc programs. If not KUSAT, IIT Bhubaneswar is offering MSc in atmospheric science. For that, you have to qualify JAM exam. So those who completed MSc can either choose MTech programs or can go for PhD programs in atmospheric science. There are a lot of premier institutes in the country which is offering PhD positions in and MTech positions in atmospheric science. IIT Delhi, IIT Bhubaneswar, Indian Institute of Science, Bangalore, IIST is also offering programs in PhD and MTech programs in atmospheric science. Mostly they ask for MTech programs, they ask you to qualify GATE. So if you have a GATE qualification, then it will be easy for you to get an admission to MTech programs. And even for PhD programs also, CSER, NET or GATE is important. So after completion of those programs, you can go for higher studies. There are in abroad also US, there are a lot of universities starting from MIT, Princeton. There are a lot of universities offering PhDs and as well as postdocs in atmospheric science. Job wise, government sector also it is there. The job opportunities are there. Nowadays, the private firms are also coming up because weather has become more and more sensitive, and now we have achieved accuracies in weather forecasting. So there is actually a lot of companies such as reinsurance companies which works on the are actually asking for input from weather request input from the weather sector. So a lot of weather companies are coming up, which provides input for these companies. Not just the insurance sectors, the energy sector, which actually predicts the amount of solar radiation reaching the surface, and which actually the energy requirement depending upon your weather situation. So if it is cold, hot weather, you may tend to use AC and fan more. So more energy needs to be produced. So it is basically a weather dependent thing. So energy companies actually requires input from the weather in weather. So there are a lot of private companies working on that. So yeah, in government as well as private sectors, there are a lot of opportunities waiting for you if you can do a good work in atmospheric science.
Okay, sir. Thank you. I think many questions are coming, but however, the time is due to this time constraints, we need to close the proceedings right now. Sibi sir, what do you say?
Yeah, I'm anyway. Either way, I'm fine. I can, if you want to continue, I can answer more questions. It's up to you.
Okay, Sibi sir.
Hello.
Sibi sir, some more questions. Couple of questions are there.
Two more are there, sir. I think what makes a hurricane to get weaker and finally come to an end? Sir, can you answer that too?
Yes, yeah, I think I have explained that in my talk, because I said that the oceans are the source for the tropical cyclones, and when the cyclone makes a landfall, it is cut off from its energy source, and that's why the cyclones gets weaker. So source of energy for the cyclone is oceans, and once it is out of the oceans, it is cut off from its energy source. Just like you have a car or a vehicle without petrol or diesel. So once it is on the land, there is no fuel, and it will weaken. It will start weakening.
Right, sir. Then we can wind up the thing.
Okay. So moving to the final session for the HOD Department of Physics, SD College, Dr. Shirley teacher is here. She will propose the vote of thanks.
Good evening, my dear friends. Guest speaker of the day, Dr. M.Govindan, Associate Professor from IIST Trivandrum. Dr. C.B., HOD Department of Physics, Kariavattom. Professor Dr. V. Ramakrishnan, former Director, IIST Trivandrum. Dr. Sheba, Assistant Professor from Maharajas College, Ernakulam. Dr. Srijit K. Pisharadi, Assistant Professor from SD College, Alappuzha. Dr. Ragesh Chandran SB, Assistant Professor from SD College, Alappuzha. I am very glad to be a part of Professor Dr.Aruldhas Memorial Webinar Series lectures conducted by Department of Physics, University of Kerala, Kariavattom, and other allied colleges. He was the heart and soul of modernization of Physics Department, Kariavattom. I am very proud to say that I was a disciple of him during my post-graduation and MPhil. I would like to express my gratitude to the organizers, the backbone of this lecture series. We, Sanatana Dharma College, are privileged to host the second in this series. Dr. Govindan, through his keynote address, gave us a clear picture on tropical cyclone and climatic changes. Even though global warming and climate changes are frequently used words, we are unaware of true facts. Here, in his talk, he emphasized the science, the genesis, growth, and dissipation of the giant whirlwind and how it affects our climate. His vast knowledge in this subject is really appreciable. I express my heartfelt thanks to you, sir. Thank you, Dr. C.B., for your felicitation and good words. Professor Dr. V. Ramakrishnan, he was an affectionate disciple of Aruldhas, sir, and we, the PG batch of that time, was blessed to have attended his class. Thank you, sir, for your good words. Thank you, Dr. Sheba, for your sweet words. Thank you, Dr. Srijit K. Pisharadi, for your felicitation to this webinar series. Thank you, Dr. Ragesh Chandran, for your welcome speech. Last but not least, I thank each one of you, the virtual participants who gave life to this session. Thank you all. Thank you once again.
Okay, sir.
Okay, so is it done? Can I?
Yeah, Sibi sir, you please.
Thank you, sir. Yes, sir. Thank you.
Yeah,
Thank
sir.
Govindan, sir.
Okay.
Yeah, thank you so much,
So
Rakesh and Sibi sir.
thank you, Shirley teacher. Thank you all the participants. So we are winding up. Thank you.